Welcome to the lecture session on the unit step function 2. That is, in the previous class, I have discussed about what is the unit step function and the various properties and how to solve or how to find the Laplace transform of a unit step function for discontinuous functions also. Now, let us discuss some more problems based on the unit step function 2. The first problem, f of t is sin t when t is varying between 0 to pi by 2, cos t when it is greater than pi by 2. By the property of the unit step function, f of t will be f1 of t plus f2 of t minus f1 of t into u of t minus a, where here in this case a is pi by 2. So same way if we write it in the solution, it is f of t is sin t, that is f1, plus cos t minus sin t into u of t minus pi by 2. So this will be equal to, when we apply the Laplace transform on either side, L of f of t will be L of sin t plus L of cos t minus sin t into u of t minus pi by 2. And we know that L of sin t is 1 divided by s squared plus 1 plus L of cos t minus sin t into u of t minus pi by 2. Now let us consider the second part of it, that is L of cos t minus sin t into u of t minus pi by 2. If L of f of t is f of s, then L of f of t minus a into u of t minus a will be e power minus as into f of s, where a is pi by 2 and f of t minus pi by 2 is cos t minus sin t, as t tends to t plus pi by 2. We get f of t is cos of t plus pi by 2 minus sin of t plus pi by 2. So when we take the pi by 2 plus t, it will be in the second quadrant. So in the second quadrant, only the sign will be positive. So both of them will be changed and it will become negative. That is, cos of t plus pi by 2 will be minus sin t and sin of t plus pi by 2 will be cos t, because our sign will be positive. So what do we get here? F of t will be minus sin t minus cos t. So L, if you are applying on either side, L of f of t is minus L of sin t minus L of cos t. And we know that L of sin t is 1 divided by s squared plus 1 and L of cos t is s divided by s squared plus 1. Taking the LCM as s squared plus 1, we get minus of s plus 1 divided by s squared plus 1. This is our f of s. Now, what is the period that is a we have here is this one, that is t minus pi by 2 s, pi by 2. So, L of cos t minus sin t into u of t minus pi by 2 will be minus e power pi by 2s into s plus 1 divided by s squared plus 1. So we get L of f of t is equal to 1 upon s squared plus 1 minus e power minus pi s by 2 and into s plus 1 divided by s squared plus 1. This is the result. Let us take discontinuous functions now, where f of t is 1 when t is varying between 0 to 1, t when t is varying between 0 to 2, 1 to 2, and t square when t is greater than 2. So f of t is f1 of t when t less than or equals to a, f2 of t when t is varying between a to b, f3 of t when t is greater than b. Then f of t is given by f1 of t plus f2 minus f1 into u of t minus a and f3 into f2 into u of t minus b. This is the definition or the property we have for the discontinuous function by using the unit step. Now, if we apply f1 as 1 and f2 as t and f3 as t square, what do we get it? F of t is 1 plus t minus 1 into u of t minus 1 plus t square plus t square plus t into u of t minus 2. Sorry, it's minus t square minus t into u of t minus 2. So L, if you are applying, it will be L of 1 into L of t minus 1 u of t minus 1 plus t square minus t into u of t minus t. We know that L of 1 is 1 by s, so let us write that. Now we need to determine the second part as well as the third part. And we know that L of f of t is f of s, then L of t minus a u of t minus a will be e power minus as into f of s. Now let's consider the first part, that is L of t minus 1 u of t minus 1, where a is 1 and f of t minus 1 is t minus 1. As t tends to t plus 1, f of t will become t. So what is L of f of t? It is L of t, that's given by 1 upon s square. So L of t minus 1 into u of t minus 1 will be e power minus s divided by s square. So now we'll consider the third part, that is L of t square minus t into u of t minus 2, where a is 2 here. So f of t minus 2 will be t square minus t. As t tends to t plus 2, so f of t will be t plus 2 whole square minus t plus 2. That is on simplification t square plus 4t plus 4 minus t minus 4. On simplification we get t square plus 3t plus 2. So apply the Laplace transform on either side. We will get L of t square plus 3L of t plus L of t, 2. So it will be 2 divided by s square, that is for L of t square, and 3 divided by s square for L of t, and L of 2 is 2 divided by s. So L of t square minus t into u of t minus 2 will be e power minus 2s into 2 by s cube plus 3 by s square plus 2 by s. Now let's combine all the results. Then we will get L of f of t is 1 by s plus e power minus s by s square plus e power minus 2s into 2 by s cube plus 3 by s square plus 2 by s. Let's take a next question. F of t is cos t when 0 to pi, 1 when pi to 2 pi, sin t when t is greater than 2 pi. So f of t is f1 of t plus f2t minus f1 of t into u of t minus a plus f3t minus f2t into u of t minus b. Here f of t, if we apply this formula, it is f of t is equal to cos t plus 1 minus cos t u of t minus pi plus sin t minus 1 into u of t minus 2 pi. So let us take the Laplace transform on either side. Then we get L of f of t is L of cos t plus L of 1 minus cos t into u of t minus pi plus L of sin t minus 1 into u of t minus 2 pi. So L of cos t is s divided by s square plus 1 and L of 1 minus cos t into u of t minus pi plus L of sin t minus 1 into u of t minus 2 pi. This two we have to determine. Let us consider the second part. L of 1 minus cos t into u of t minus pi. So a is pi. So f of t minus pi will be 1 minus cos t. As t tends to t plus pi, so f of t will be 1 minus of cos of t plus pi. That will give us 1 plus of cos t, because pi plus something, it will be in the third quadrant, it will be negative for the cos, therefore negative into negative it is positive. So it will be 1 plus cos t. Let us take the Laplace transform on either side. It will be L of 1 plus L of cos t. We know L of 1 is 1 by s and L of cos t is s by s square plus 1. This is a f of s. So e power minus pi s has to be multiplied. So L of sin t minus 1 into u of t minus 2 pi will be e power minus 2 pi s into 1 divided by s square plus 1 minus 1 by s. Therefore, f of t, L of f of t is s by s square plus 1 plus e power minus pi s into 1 by s plus s by s square plus 1 plus e power minus 2 pi s into 1 by s square plus 1 minus 1 by s. Because we know that a sin t Laplace transform is 1 by s square plus 1 and 1 is 1 by s. So into u of t minus 2 pi will be e power minus 2 pi s. So that gives us the result as this combination of all these three. Thank you.